Hello? 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 Okay, it's just a bit. Perfect. Good night, Professor. You can hear me? I think I can hear you. I see you are talking. 1 second, let me see if it's mine. Guys, help me. 1 second here. You can hear me and Professor? Guys, help me. 1 second here. You can hear me and Professor? Guys, help me. 1 second here. You can hear me and Professor? I think it's working, Professor.
We are in the backstage or we are online now?
We are online.
Okay.
You want to try in the backstage first? Or
I
it's
think
good?
it's better.
But we are still reaching the views.
Okay, so it's better to try in the backstage to see if everything is working well, okay?
Okay.
So,
1 second.
well, how can I do to make my presentation?
É em apresentar na barrinha de baixo, eu acredito que vai estar aparecendo.
Então a gente pode falar em português agora? Tá, apresentar, slides de arquivo vídeo ou compartilhar tela? Compartilhar tela, minha tela. Permitir. Ok. Vocês estão vendo a minha tela agora aí ou ainda não? Agora sim. Então, se eu colocar aqui minha apresentação e colocar no modo de apresentação, ela vai ficar a minha tela, né? Eu consigo colocar duas telas, fazer a apresentação em uma tela e me ver na outra? Acho que sim, não dá?
Sim, é só você, depois que você colocar apresentando a sua tela, você volta para essa plataforma que a gente está conversando aqui.
Tudo bem, eu vou tentar fazer isso aqui rapidinho. Nós estamos no backstage aí, né? Só um minuto.
So,
Tá
professor?
tudo certo aí, Yuki? Não tô te ouvindo.
Certo, tudo certo. Agora tá?
Você está me ouvindo? Tá tudo certo?
Tô ouvindo, tudo certo.
Deixa eu ver aqui, porque acho que eu não estou te ouvindo. Deixa eu mudar a configuração do meu áudio aqui, tá? Para eu conseguir ouvir vocês. Vocês estão me ouvindo?
Já gravou? Não. Parece que estão ouvindo, sim. É que demora um pouquinho para chegar tudo.
Você está me ouvindo?
Sim.
Você está me ouvindo? É que eu não estou te ouvindo. Eu estava tentando ver se eu consigo ouvir vocês aqui. Mas se você está me ouvindo, tá tudo bem, tá? Mas depois eu não consigo ouvir se tiver alguma pergunta, alguma coisa de vocês. Então eu queria só mudar a minha configuração, porque como eu coloquei duas telas, provavelmente mudou a configuração aqui. Deixa eu ver se eu consigo trabalhar a configuração de áudio, tá? Por gentileza, comenta alguma coisa só para eu ouvir.
Tá me ouvindo, professor?
Sim, agora sim. Agora eu consegui mudar a configuração. Então tá tudo certo, tá? Tudo bem? Então, tá tudo pronto aqui para a gente começar, tá? Então, a hora que
Eu
você...
gostaria de... Tudo ótimo. Mais 3 minutinhos, pode ser? Pra gente começar às 6h10,
Tudo bem.
normal?
Aí você me chama aqui em 3 minutos, tá bom? Obrigado.
Tá ótimo, obrigada. Professor?
Hi.
Everything good? I think we can begin. We already have some people in the meeting. So, first of all, good evening, everyone. Welcome to the third international webinar of this year, this time with the theme of Production Challenge. It's a great pleasure to have each of you here with us. And I really like to deeply thank all the participants to join us today, and especially the speakers, of course. And the expertise you're bringing and the values insights of the crucial topics you're bringing today is going to be valuable for all the members, and this contribution is essential for the success of this event. So first of all, guys, I'm going to give a little introduce about our first speaker, Professor Márcio, and he will discuss the topic of measuring forage mass in pastures, a key to successful livestock farming. In the lecture, Professor Márcio will explore the importance of measuring forage mass in pastures as a crucial factor for a successful livestock farming. Professor Márcio Lara holds a bachelor degree in agronomy engineering from Federal University of Tocantins, a PhD in animal science and pasture from Exalc USP, and completed his postdoc in forage plants and growth modeling in the University of Florida. He's currently a professor of UFLA of forests and grazing, and he contributes a lot with the practice and advancements in science in fields of grazing. So thank you so much, Professor, and it's yours now.
Okay. Hello, everyone. I hope that everyone it's fine here to be with us. Thank you for the invitation. It's a pleasure to me to have this good time to express a little bit more about my work at UFLA and during the most part of my life. What? All right. So thank you for the organization, people that helps me with this process, this program. And I'm using two screens. So I'm looking for another screen, but you can see my pointer here and follow my steps when I'm talking and showing something in the presentation. All right. So again, I'm talking today about the measuring forage mass in pastures and uh, the importance of the measuring, the efficiency of measuring forage mass in pastures, because this is a key for the successful livestock farming. So this is a great opportunity to me to express a little bit more about my work at UFLA as a scientist and as a professor and a good uh, we can have a good overview about the measuring forages in pastures in our case and in Brazil. Okay, so my presentation, I know that you worked with this few minutes ago, but I'm agronomist. I'm graduated in engineering, agronomic engineering, agronomist. I I am a professor since 2011 at the Animal Science Department at UFLA, and I'm working with forage science and pasture management. I did, I worked with some professionals in the United States in crop and forage modeling during 2016 and 2017 when I returned to Brazil and I started to apply the modeling systems in forage directly with tropical forages in Brazil. I'm former scientific director of the Fundec, is the a foundation of that supports researchers in Brazil. In our case, at UFLA. So I was in the past. I formed like a director of the nucleus of the innovation center. So like an NIT in Portuguese. So I was a director there for 3 years, and then I was the first pro-rector of innovation and entrepreneurship at UFLA, the only one and the first. So I'm very proud about this, and this is my work. I worked with innovation and entrepreneurship in the last 3 years, I step aside a little bit forages, working with forages, but now I'm catching up everything and restart to work with forages again and receive some students, some foreigners. I have now opportunity to work with one guy from Nigeria and can speak with English in English with him during all the day. And this is very nice because my English is a little bit rusty, but I'm trying to do my best here, right? And in the end, I'm passionate from animal production systems in pastures, and I consider myself like enthusiastic guy. So about all the overview of my work, I can help you to understand a little bit more how is the process to measure forage mass in the pastures and the importance of this for us. So before everything, I need to show you some data about the importance of measuring forage mass in pastures, like a key to have a success in livestock systems in the farm. So we created in 2014 some questionnaires about the application of technology, use of forages, forage measurements, some kind of management of pastures and everything to several farmers around Lavras, Minas Gerais state, in several cities near from here. So what does the mean optimizing a production system? When we asked to professionals about this, they answer a lot of things. But it's very interesting to us to understand that to optimize the forage production and the system production of animals, we need to achieve the highest possible yield per unit of available productive resource. This is the optimizing the system. So we need to have the best conditions to forage production, and to know this best condition, I needed to measure. Okay, so to optimizing means understanding the production system, and it's in a multidisciplinary nature. So I need to understand water supply, I need to understand soil systems, we need to understand how everything works together. So about the plants, about the animals, about the management, about the automation systems, automatic systems, tractors, a lot of things we need to understand working together to optimize the system of production, right? So this is a system of cause and effect. If I cause something, I have one effect in a row during all the year in my forage systems. So I applied, like I said, in 2014, a questionnaire about farmers, how they work, what kind of plants they used, how they used to measure pastures and everything. So we had more than, in this case, a lot of cities. You saw here several questionnaires from Ibituruna, Ingaí, Perdões, Lavras, and everything. So we had a lot of farmers working with us in this questionnaire applied in 2014. And we divided the farmers by farm size. So we had a number of the farmers of 30, 27, 25, are around the same number of the farmers, and we divided in the farmers from less than 25 hectares, from 25 to 15 hectares, and higher farmers bigger than 50 hectares of forages in the systems. So we divided on this way the farmers to have a good overview about the forage production and the forage measurement and the kind of forages that can use, divided by these three sizes of farmers, okay? And the interesting to understand before everything is that when we ask to farmers, what is the number? Yeah? What is the number of the forages that they can use in their own property? It's important to see that the small farms had just one or two forages present in the pastures. So if you go into the big farmers, more than 50 hectares of pastures inside the farm, we have a more distribution. In some farms using 4 and 5 forages, kind of forages. This is a very important thing to say, is that lower, small farms, we had just 1 or 2 kind of species used by the farmers. So you have more space, more land. We can have more diversification of plants. This is a very interesting point. Why am I doing this? Because when you ask to the farmers about what do you think and about pasture productivity, so this results in the percentage. Most part of the small and the regular and the big farmers called answer the questions to us, talking about the 72%, and small farms 53%. So most part of the farmers believes that the productivity of their pastures is low. Okay, small farmers has more balance between the high and the low productivity, but the highest producers, like the big farmers and the regular ones, believes that the pastures are not productive enough. When we ask to them about the observation of degradation in the pastures, most part of them, more than 60%, believes that they have some problem. They have some problems with degradation. So these antagonic results showed us that the farmers had some problems with pastures. So they believe that the pastures are not so productive, and at the same time, they believe that the pastures suffering with some kind of degradation. In the end, we asked to them, what is the criteria for entrance of the animals in the pasture? So what do you use to decide the entrance of the animals in the pasture? So most part of them in the small, the regular and big farms answered that the visualizing, just take a look at the pastures and imagine that, okay, you have a lot of biomass, or we have a good amount of biomass in my pasture, so I decided to put the animals in the pasture. So we had low number of the farmers working with fixed days or something like this, so they decided to enter animals in the pasture based on visual things. In great part of them, they don't they decide to not answer the question because they don't know, they don't want to show to us how they work, and this is not the good way to offer working. Okay, so that's the problem that we have in the most part of the farms in Brazil. People doesn't measure anything, and this is a big problem. So we made more 2 questions to them in 2014. So do you measure forage mass? Believe it or not, 97% or 100%, independent of the size of the farm, they don't measure forage mass. And what we can do without this information in the farm? If you don't measure, you you can manage. In this case, these professionals are working on based on their own minds, and they work without any data. And this is very this is terrible. This is not so good for administration of the farmers. Okay, so do you receive some technical visitations? What these visitors, these technicians are doing in the farms? Because most part of them, okay, is around 47, 30, and 32% of them receive technical visitation, but they don't measure anything. So what those guys are doing in the farm? So we had some problems on extension too. So this is a big picture about what's happening with the forage systems in Brazil. So we decided to reply or do again this questionnaire in 2024. So we have more than 10 years length to observe the differences between results in 2014 and 2024, and we observed that the changes are so slow, or so small changes. I'm sorry, so small changes. So the technician, the use of the technology or knowledge about the forage measurement is too is not so used. There is low adoption of forage measurement in pastures in 10 years in the same region. So 10 years later, we had 66% of the people don't don't measuring forage production in the pasture. So this is terrible again. So 10 years of my work, 10 years of work of professors in forages and researchers to improve the systems and provide the people, farmers, new cultivars, new forage management strategies and everything, and they still don't measuring anything. And this is terrible for us. So some of them using some destructive sampling, 10%, and 22% use canopy high, sort of visualizing the biomass is great. So we put the animals when the biomass going down and have a small residue post grazed material, they remove the animals from the pasture. So this is totally unacceptable when we have a lot of researchers and innovation in this area in the forage systems in Brazil and around the world too. So decision about animal entrance in the pastures, we asked them again, and they answered in the same way without any criteria. So the entrance of animals in the pasture are made by the head, the thoughts and thinking that farmers thinking that's a good way to do and measure forages in their own pastures. And this is not so good again. So we are working 10 years, more than 10 years, doing the good things with the students in extension, and sometimes they don't accept the basic line of the managed pastures. The forage measurement is very, very important. So 61.2% of them don't receive technical visits during 2014, 2024 questionnaire. So what's the main limitation to encounter in managing the pasture in your property? This is a very, very specific question, and we have here is stay in Portuguese, but we have some results. The financial is the first one. So it's 48% of them answer the question, telling us that the lack of money or the fault of the investment is the big problem to have good persons, good technicians in the farm. So the second is the lack of the specialists in the farms. As the fault, we have some lack of assistancy, and then another things here that less important. Okay, but lack of money and investments is the main problem that we have in the farms. Looking at this, when we asked to them what is the average number of the technical visits per year, 60% receive some visitations during once a month. So this is a low number when we need in the pasture systems some evaluations day by day, week by week, and we have the visitation just once a month. This is not enough. So other farms working with 4 times a year, just one visitation each 3 months is it's not so good. So you need to have constant measurement, and the people needs to be in the farm to have these responses of pastures, and we need to collect the data every week, every day, to have a good overview about the forage production in the pastures. So when we go directly to the sampling to understand how we can do this, we need to go to the pasture and select some spaces, some different spots on average of biomass, and we can use some frames like this one is a frame from half meter per 1 meter. So we have here half meter square of area, and we can just select this place, this spot in the pasture on the average, and then we can collect and harvest the material inside this square. So this is the main way, or the most common way, to have the good overview about the forage production. But this is so expensive. The farmer expend time, expend money, they expend people to do this in the pasture, and you need to do this on the pre-harvest and the post-harvest situation. So a lot of work to do collecting data on this way. But this is the very good way to have an overview about forage production in your system. And most part of the farmers don't do that. So if you ask to people that work with coffee or soybean or rice and or everything, or another culture, okay, agriculture, another culture, they always have the information about how much or how the quantity of the grains you produce per hectare. But here in the pasture is not so common, right? So when you have this directing sampling, so I choose the space that I'm collecting the data. I'm using some machines to harvest the material in the soil level. And then in this case, we are using this kind of machine that harvests forages in the soil level and uses some bags to save the material and have a waiter to have the good number of the forage production on this area. So we can use this production to have a good overview about the entire hectare or the entire pasture if the pasture had more than 1 hectare of the size. So we are using some samplings to do that, and we can dry this material and have a dry matter of this area of the biomass or fetal mass and of forages to have a good overview about the forage production. So as you can see here, we can collect many samples to have a number of the samples corresponding to the variability of the pasture. So this is it's not so good to have just 1 or 2 sampling per hectare or per pasture. So you need to have more than 5, sometimes 10 sampling to have a good overview about the average production of pastures. And here I have a small video, short video about how we can do this using a scissor, for example. So this is, I have some help during this video, but I will show the video. Probably we don't have some sound, but it's just to show you how we collected this data. So here we insert the frame in the soil surface. So this is the Sergio, my friend, and one student that helps me to collect the data. And for collecting using scissors, for example, is a very simple instrument. Time expended to have this sampling was around 10 minutes. So here the video is going very fast, and you can see how the place or the spot stay like this. This sampling is the same thing from this side. So we have a good overview and good sampling of forages in this case. So this is the same frame. So the half meter by 1 meter. So the entire area is half meter square. Okay. So this is the way we are using some bags to take this material and have, we weight this material in the labs, for example, and put this material in the oven to dry, and we have a biomass, a dry mass material per sample, and then we can extrapolate this per hectare. That is the way that we are sampling forages in the field. But we have more specific things that we can do to reduce this kind of the labor, expending time and expending people doing this in the experimental fields or in the farm. So we have a rising plate meter. That's a structure that we have like a plate here. The material is metal or aluminum, for example, that we can work here. They have some weight and they compress the biomass. Are you seeing here? They are compressing the forage. So we measure with this equipment the density of the forage, and using one special equation calibrated for this kind of forage, we can reach in the average biomass doing sampling, just walking and have some measurements in the pasture. So very fast. I don't need to cut anything here. So I can just drop in this plate and going. I'm doing for example 10 steps and do it again, and it's possible in the same 10 minutes of the one sampling directly cutting the biomass. I can collect, for example, more than 100 points or spots in the pasture. But to use this kind of equipment, I need a calibration for each species of forages, right? So I had another video here. This is very interesting. That's a farm in Europe, and this is one agronomist, and they have this course. It's very interesting, and he telling us you can't manage what you don't measure. So this is very strong and powerful. So we need to measure things to have a good management. Without measuring, we don't have a good management of pastures. So they are using in the Europe the same system of the rising plate meter in this case, but I have another sampling that the guys use. I have a short video for you here. Okay, I'm just cut the video. They are using two kind of technicians to measure forage yield. So you saw the rising plate meter, and here is a short video about the forage sampling directly, like I made with my friend Sergio using the scissors. So I have this kind of instrument at UFLA, and we can use this in the farms. Don't worry about this. It's not too expensive to buy a machine to harvest forage. So here in Brazil, it's around 600, 700 Rios to have one machine, totally automatic, and using some batteries to work without energy, right? So that are some kind of instrument that we can use to have a good sampling in the experimental or in the pastures directly on the farms. Another approach is working with canopy high. Canopy high is not so directly associated with density of forages, so you have more mistakes and wrong measurements using canopy high than using the rising plate meter or collecting data, just cutting and harvesting the material directly. but it's a good approach for forages with the low high, and forages that we have more one density, more spread around all the plants. So for grasses, the tiny grasses, there is a good approach to use. So we're using a lot this in our systems at UFLA, in some farms, to accelerate the process to having data. So this is very, very interesting, and we can use better than not using any process to collecting data or sampling forage, right? So this is the interesting to see that measuring forage from any of these three ways, okay, gave to us a good overview about the distribution of forages during the months or during the entire year. So we have here, for example, in Minas Gerais state, in our region, January, February, March, a lot of rain, so we can produce a lot of forages during June, July, and August, for example. September, we don't have so much high temperatures, so we have low temperature, low precipitation and water supply, and this we can drop the production, the forage use going down during this time of the year, and then going up again in this period, September, October, November, and December. So this is the average forage production in our city here in Lavras, and then when we apply nitrogen, for example, I increase the forage production during the summer with higher temperature, water supply, and photo periods. So this improves the production of forages, but during the winter, the production with nitrogen will not change anything because we don't have some weather climate. We don't have some characteristics important to have a good production of forages during this period. So we can variate the production using, for example, irrigation. If during this period of the year we have the dry season but higher temperature, like in the states in the north of Brazil, for example, the problem is water and it's not the problem. A big picture, a temperature, because temperature is higher in the Cerrado and the north of Brazil. So irrigation can solve the problem. And so we can diverse using different species, but in the end we need to measure everything independent of the situation, the system, irrigated, not irrigated, if it's rain fed, if we use some supply of nitrogen, for example, or different species. We need to measure everything every day and to have a good overview about forage yield. Here is some results of the research that we made a few years ago. And here we have, for example, dry lands. And dry lands, we have a mapping of Minas Gerais state, and we are using 0 nitrogen, 50 nitrogen, kilograms per nitrogen per hectare year, going into 350 kilograms of nitrogen per hectare divided in the entire year. So if you increase nitrogen level, we can produce more biomass. Okay, so if I don't measure this, I don't know how many animals I can use in my property. Okay. Another situation is take a look at the same in the spot on the arrow here. When we change the slide in the same state, but using irrigated system. Look at this. When I put water and I have more nitrogen, I have in the north of Minas Gerais state, for example, a lot of production. And this is the modeling systems that I can, there is some assumptions about production and forage yield. It's not possible to measure in the entire country or state like this, the forage production year by year. So we are using some models to simulate how the productivity can be high when we use nitrogen associated with water. So this have This gives to us a good overview about the potential of productivity. But to have this potential in the experimental or in the farms directly, we need to measure. We using, for example, dropping the quadrant or using the rising platimeter or just measuring canopy height and make this correlation with productivity, right? Here's some examples. I highlighted two of them. So Espinosa in the north of the Minas Gerais state and Monte Azul with 0 until 500 kilograms of nitrogen per hectare year. We produce more than 6,000 until 26,000 kilograms per hectare per year when we use more nitrogen, in this case, irrigated. But if not irrigated the system, we are using just the rain fed or just the precipitation, the water supply from atmosphere. We can produce the half part when we are using some irrigation. So Espinosa is a good example on what areas we can use the system of irrigation to improve the productivity. So Monte Azul, for example, the difference between irrigated and not irrigated are not so big because we have probably problems with the low temperature, reducing productivity instead of nitrogen efficiency and water supply. So what we learned with this, I'm going to the end of my presentation. To optimize forage measurement or to optimize forage productivity in my farm, I need to measure the production. So this is very, very important, measure the productivity. Plants needs nutrition, so nitrogen, fertilization with phosphorus, potassium, and everything will be very, very strategic to have a good forage yield during the year instead of distributed along the year in the summer and during the winter too. The forage management to understand the plant and then understand how these plants can grow up during the seasons will be very, very interesting and important to have a good overview about production. And we need to invest in technology and assistance. So people that works with livestock needs to understand how everything works inside the farm. And measure forage biomass is one of the most important things that the farmers need to do. And sometimes, like I told you in the beginning of my presentation, most part of the time they don't measure anything. So they are just kidding, just doing things going the wrong way without any perception about forage, about the sustainability, using the efficiency of the use of the money and some resources in the farm. So I bring here to you one very interesting comment about Mario Sergio Cortella. Do your best in the conditions do you have while you don't have better conditions to do better, okay, to even do better. So this is very, very interesting overview about the forage management and how important it is to have a good measurement of biomass in the pastures. Thank you for the opportunity, for the time, and I'm here to answer the questions if you have. Thank you.
Thank you so much, Professor. Great lecture. And so, guys, any questions you can send? I think we can see everything in the chat. So, you're a guest. Professor, if you don't mind, until some questions arrive, I have one question.
Okay.
It's about Europe. You're saying they did the measuring. It's something common there. They already understood this, what this is essential and use and apply, or is not the percentage is similar to here that people don't really use.
Okay, it's a good question because when you're thinking about Europe or another country that have a small size compared to Brazil, the people needs to do something better. So to have a good um, to use better the soil, each meter square in the pasture, we need to measure something. So the Europeans had this evaluation very well done in the pastures, and then they measure, and they manage pastures better than us in some situations. But in Brazil, in our case, we have we have a vast proportion of landscaping, and we have a lot of forages, kind of forages, and area to produce forages in Brazil in several parts of the farms. And so um, that's a view, a problem. Okay, so we have very good researchers, we have very good stations, we have of working, we have very good professionals that work with this, but sometimes the extension can't help the people there because they don't have access of this information. So if we had information enough to measure forage biomass, forage yield during the entire year, probably our system will be very, very efficient, and we can reduce the quantity of hectares using by forage systems, and maybe we can save some landscaping, and using, for example, some areas to reforestation, using to agriculture, so we can improve our livestock systems just measuring forages. Okay.
Okay, and one more that you said that we if you disseminate this knowledge, right, we are going to go get more productivity. You see, like a year, like how much time we are going to take to disseminate this information. What you see for the future?
Okay, I'm enthusiastic guy. I would like to think that um, keep doing my job, my research at the university can help the people. So I'm a researcher. I'm not an extensionist. So I think that the extensionist needs to do a very good job talking to us, or getting more around us, staying around us, just to have this information, just to chewing this information and give for the farmers in another way. So I can do this too, but I need to expend more time with the students and the researchers than the extension. So I think that we need to improve all the systems, okay, education, researches, and extension to have a good overview in the few years. So we are very late with this, comparing Brazil with other countries. We have a very, very good researchers and a very, very good results of the research, but we don't apply directly in the farms, okay? So the point is this: we need to have more people working with this in the fields. We need to have more investments by the governments. I don't know how to to contract to have more people working with this and giving this information to the farmers, so they can change their lives if they start to just measure forage biomass when they are working with the livestock systems.
Great, thank you very much. And we have some questions in the chat. If you can't see it, I tell you what they are saying. I
Okay,
see
I'm
two.
taking a look here. So if you want, I have time. I don't know if you have time to have one more
We have a
question.
little. I think we have a time for one
Okay,
more question.
so select another one and we can answer the question.
So you have here Julia Passos. You can see it.
Okay, Julia, I have a question. What do you think is the main reason that the Brazilian producers in general don't want to invest on technology and measuring and managing The height, is that
Right.
highway? Okay. The right way of the pastures. Okay, yes. Okay, good question, Julia. I think that like I showed you in the presentation, the most problem that the farmers advocates about the problems to not invest in new technologies or knowledge about the forage management is the lack of money. They just advocate about this. So the lack of money, they prefer to use the money to do something different, to invest instead of investments in forage management. So this is not so good in my point of view because livestock systems in pastures are very profitable, okay, but they don't have this knowledge. So because of this, it's much important to us to have more people understanding this, studying this, researching this, and passing this information to the farmers. Okay, probably this can help them to improve the systems, put a little bit more money investments in technology and knowledge. Okay.
Okay. So in time, perfect. Thank you very much, Professor. Your lectures were great. I'm sure that a lot of people here have valuable insights about what you said. And you, it's great your research, and we just see you. It's always here if you need something. And thank you very much for your disponibility.
Okay, thank you for the invitation. Again, I'm open if you want to have another subject in the future. So thank you everyone for staying during this time with me. I'm spending this time, but investing this time with me here. Thank you so much.
So, guys, now we are going to give a little break, 10 minutes, and 7 and 10 we go back, okay? Hi guys. So we already have our 10 minutes here. So we are going to start again. I'm going to call our second speaker, Juliana, and for introducing her, of course. So, but first, thank you very much, Juliana, for being taking your time to come here and talk with us. It's going to, I'm sure that your lecture is going to be bringing valuable insight for all of us, especially a lot of technology. You're in US, right? So
Yes.
it's great. So, Juliana, we discussed about machine learning for soybean flowers and pod phenotyping through imagine analysis and target fire abortion, guys. And in these lectures, you're going to explore the use of the machine learning techniques in the phenotyping of soybean flowers and pods, with the goal of reducing flower abortion. Juliana holds a bachelor's degree here at UFLA in agronomy and a PhD in plant production from UFLA too. And she completed the postdoc research in associate research at Texas University and Crown Center for Research and Industry Innovation. With a strong academic background and research experience, Juliana has significantly contributed to advance the phenotyping techniques and imaging analysis applied to agriculture. So thank you very much, Juliana, and it's all yours.
Thank you very much for the invitation. It's my pleasure to always come here and have the opportunity to present at UFLA. So I'm here in Texas, Lubbock, and I came to work with this project, and it's very challenging, but it's very exciting at the same time, which is using machine learning agriculture um, in soybean. So let me give you just a introduction. As everybody knows, that soybean is a crop very important around the world and would not be different here in the United States, right? So the forecast for this year in 2024, it's a record of 4.59 billion bushels, which means 124 million tons. This is a 10% increase compared to 2023. The productivity that we have here is 3,577 kilos per hectare. And if you see in this graphic, let me put my pointer here, from all over the years, the production here in related to soybean, it doesn't vary too much. It's mainly between 3.5 to 4.5 billion bushels. And what they use the soybean for here. So they use 30% for feeding animals, 18% for soybean oil, and 50% for exportation, and 2% for human consumption. So it's very diverse the way they use the soybean grains here in the United States. Also, in terms of exportation, we know that China is the biggest buyer, and Brazil it's the one that holds the 73%, and United States still holds the 51%. So we know how important soybean is, and doing this kind of research related to use machine learning and other technologies so we can improve yield and productivity, it's one of the biggest goals here in the United States. But for many years, there is not much research related to flour in soybean. Mostly you will see it's more related to pod, to grain production, but nobody wants to touch in flowering. Why is that? Because if you see here, the flower is so small and it's so hard to count because it doesn't flower just everything at once. It comes along the season, many bloomings. Here is an example of what is the color of the soybean if you haven't seen it. So it can be purple and can be white. And these are the stages from bud to pod development, the first stage of pod development. If you see here, it's an example of what a flower, what an aborted flower looks like. So it looks yellow, dried, and after this stage, it just fell from the plant. And we know that if we don't have flowers, we don't have yield, right? And this is why we're researching, because we need to find genotypes that can hold flowers so we can have more yield. And how do we do this count? So we need to have the total number of flowers, which you can see here is very small. Imagine like you having to count this every day, for example, if you want to have an accurate track. It will be very tiring, and this is one of the goals that why we're using machine learning. And also, after we have the total number of flowers, we need the total number of pods. So total number of pods, it's easier because you just go by the end of the cycle and get the total number. And then when you subtract both, you have the flower abortion. What are the causes of flower abortion? So there are many causes of flower abortion, but the two most important are the draw stress and high temperature, which are the ones that we are studying here in Texas Tech. But like, how do we quantify flowers and pods? As you can see, a breeding program can use flower count. Pharma can use flower count. A researcher can use it, but it's very tiring to do that manually. You will need to knee every time to go there and count every single plant. So why not use machine learning? And with machine learning, we need to create a tool, which is imaging. So we're going to image the plant so the model can count all the flowers and we don't have to do these manual counts anymore. This is a multi-regional project, so there are more universities involved, as like Kansas State University, the University of Tennessee, University of Missouri, and Texas Tech. Why we chose all these regions, it's a partnership between professors, and also we want to have the same genotypes that we are studying here in different environments, so we can see if the flower abortion is different between these locations. Texas Tech will be the place where we would improve the stress, because here, like, every day during the summer is 40 degrees Celsius. It's very hot. Rain, we only see like maybe a little bit in the beginning of the summer, no rain during the summer, and we only have rain like in the end. And it's not much. So mainly here in Texas, when we work with crop, we use irrigation. And also this project is supported by the United Soybean Board and the North Central Soybean Research. So we have farmers investing in us to figure it out, how can we count soybean flowers. So for 2023, we have this going, how can we image this? How can we get to image? We need to develop a platform. So we decided that each location would develop a different platform, and then in the end, we would choose the best one for imaging. For example, here, Texas Tech used a tractor where we mounted the cameras. We used GoPro cameras, and the image that GoPro was doing, it's overlapping always, because in the future, we want to get the videos from both cameras and stitch them as a big image so I can have the whole length of the plant. For example, here, Kansas State used a sprayer. And Tennessee, they decided to go for a Aussie car, which is mainly a toy car for testing. Also, we received 228 lines of soybeans, which means a variety of soybean seeds. If you only saw yellow soybean, believe me, there's so many colors, and I was so impressed. It's so beautiful. They're like green, and it was very nice to work with these seeds, as I'm a seed specialist, so I spent a lot of time like taking pictures of these seeds, but we planted all of them in all the locations, and our goal was to do the manual count and the imaging those genotypes and length. So to make our model to work, we need to have the ground truth. How do we do it? We do manual counts. However, we cannot get like a 8-feet plot, which means 2.5 meters, and count all the plants. That will be an impossible job for 228 lines, right? So we decided to choose 3 plants per plot, and we had 3 reps. And we could not do it as well, like counts every day. So we decided to do every 3 days. And in the end, when we are close to harvest, when the plants were dry, we just count the pods of these plants. After we got all the image done during the season, also just a reminder, every time we did the manual count, we also did the image in the same day. So we could have the similar flower count for like from manual and from the model. But when we get the images, we still need to train the model. I need to teach the model what is a soybean flower because the model doesn't know what it is. We tested few models. The best ones were for detection was Fast RCNN and YOLO. But all of the ones that we tested, they performed the same. These ones were like slightly better. And it's more like a preference from a computer scientist preference, if I might say. But then I needed to train, which means doing annotation. What is annotation? Annotation is drawing these bounding box that you're seeing here. So I would have some frames from all the locations and do all these bounding box. Every time I see a flower, I would draw a bounding box. And then this is me teaching the model what is a flower. It can be an open flower, a closed flower, a dry flower. As long as a flower, the model will learn all the patterns, the morphology, so it can predict later. So here is the model prediction. In your left, you will see the ground truth, which means what I annotated in these blue bounding box. And here's the prediction of the model. You will see that even when the flower is blurred, you cannot see it quite well, the model was able to detect it. And here's another example of the detection. The model was working good as well. But again, it's a process of training and it's not 100% accurate. So you can see here where I have 4 flowers that I annotated. The model was not able to detect here 4 flowers. It detected 3 flowers. But still, this is just a frame. That's not what we're not taking pictures. Taking pictures in the field would be something very tiring. We're doing images. We want the model to be able to detect in a live video. So here is an example of our first video doing the detection. Oh, sorry. Let me click play. Okay, so here you will see the model finding the flowers and detecting them. And sometimes you will make a mistake. Of course, it's our first video. We're still training. You will see that sometimes it gets confused. It doesn't know if it's just 1 flower or 2 flowers. So to fix this problem, we need to train more with more frames so the model can learn more like what is a soybean flower. And then in the end of the season, we decided, well, why not we just do this for pods? Because in the beginning of the project, it was just about counting flowers. But then we decided, let's make a program that can count the flowers and can count the pods and can give us the abortion in the end. So we started using bounding box, but if you see here, the pods, they have a lot of overlap and it's very hard to draw all the bounding box. So we had to move to another approach, which is segmentation. So here segmentation is basically me drawing around the pod. And for that, we have programs that we use for this kind of work. And this is, again, just us, again, training the model to say, hey, this is a pod. And then the model will learn so it can detect pods in the future. From our manual count, the data that we collect from the 228 lines, you will see that the flower abortion percentage varied from 20% to 80%, which confirms what we saw in the literature, that we can have this variation. But here you see that you have this variation across 228 genotypes, which means that we have the genetics of the lines being very important in terms of having higher flower abortion, lower flower abortion, and this is very interesting from a breeding perspective. Here is another graphics about the now comparing two locations, Tennessee and Texas, just a few lines. You will see that the average abortion in Texas Tech was 48%, and in Tennessee was 17%, which makes sense because here in Texas it's hotter, we have drought problems. Tennessee, it's more optimum condition. So for 2024, we needed to make improvements. As I told you before, we had all this platform that we tested. We needed to figure out, okay, which one is better? Which one can help us to do this image without damaging the plants, without disturbing them? Because the more you see that we are imaged every 3 days, if you're disturbing the plants all the time, that will naturally cause flower abortion as well, right? So we decided for the RC car, the toy car. However, last year we used a race car so it's very hard to slow down a race car because it's made to drive fast. We tried everything, but we cannot slow down. So I had to do a research and see if there was a RC car that drives slow. So I found this one. This is a RC crawler. And if you can see here in the video, it drives very slow and crawls anything. So if for an uneven field, this is perfect, literally. Also, the next improvement was to add more cameras, because last year we had lines that were very tall. And here in Texas, due to the stress, they don't get as tall as they should be. In Tennessee and Kansas, they get like very, very, very tall. And then we thought, okay, we need to add more cameras. Just 2 cameras is not enough. So all the locations about the same platform. This year we are using the same RC car. It drives slow. Why do I need to drive this car slow? Because if I'm driving too fast, I'm not gonna have as many frames as I want to give me the details so I can capture all the flowers. Because a video is just a set of frames. I believe for GoPro, the set, it's like 60 frames per second that this camera is able to do it. If I'm driving too fast, I'm missing a lot of flowers because it cannot capture. So our goal is to drive slower and to have more cameras. And also, because we are working with 4 locations, and it was very hard for us in the videos to know, okay, which plot is this one? We decided to make a label and put a QR code that the model can detect and know, okay, this is plot number number 1. And then I know that plot number 1 is genotype number 567. So this helped us a lot. As long as the camera can capture the QR code, we can identify all the plots that we are imaging. And here is an example of how the platform look between the rows. You see that it's minimal, the disturbance that the RC car does. And here's another video of me driving the RC car. So you see that it's slow, it doesn't harm the branches. Of course, that if I have a genotype that the branches are very low, the car can probably hit it. But most of the genotypes, especially the ones that we use for production, they don't have these kind of branches. These are only kind of wide lines that we have here that we are testing. Those ones were not good for any kind of driving platform that we tested. Okay, so you know that 2023, we did the annotation for detection. We got better on that. We had like accuracy close to 85%. Good. But we just don't want to detect flowers. We want to be able to count them, right? For that, we need to go back these videos, in these videos, get some small videos of like 2 or 3 seconds and annotate them. So in 2 or 3 second videos, I can get around 300 something frames, and that's the job, like putting these bounding box all everywhere where I see a flower. But it's not just that. The next frame, you will see the same image, but the flower will move a little bit. So I have to adjust every single bounding box that you see here in this image. So it's a much harder work than just detecting. And for this kind of tracking, we tested a few algorithms, and the ones that we had the best results were like OC sort and sort. But sort was the best one, and this is the one that we're gonna be using for flowers. And if I'm not mistaken, the team that is working with pods will use sort as well. Here is an example of the video when you see the model tracking the flowers. So every bounding box that you will see, you will have a number, which is the number of that flower. So pay attention to, like, you see that there's occlusions, and then when the flowers show up, the model can count. That was one of our concerns when we were training. Like, if I have a leaf that occludes that flower, and then that flower show up again, would the model be able to detect that? So with our training, the model is doing that. And here's another example of the same video, but the model counting the flowers. Here below, on your left, you will see the numbers increasing as the car drives, and the model can detect the flowers, and you will see the counting. And this speed that you see here is still fast for us. It's one of the videos from last year. This video's image will be much slower. Let's see, in the end, we'll count 89, 90. So just this video, which is basically a 2.5 meter, it counted 109 flowers. And this is the initial phase, like of the reproductive phase. So it doesn't have many flowers, but when it peaks, this number can spike to 300, 400, 500 flowers. For the same thing that we're doing, annotation for tracking, we are going to do for pod. We're a little bit late for pod because it's, as I said, it was an idea that we had before. But right now we're just training the model for tracking. And as you can see here in this image, there's a lot of overlap. It will be a very tiring job to figure it out how to count these pods when they're like, you see only the tip of the pod. How can you track that and make sure that you're not counting like the tip of a leaf? But these are the challenges that we're having, but I'm pretty sure that we can overcome. It's just a matter of training the model, finding new tools. And this is just an example of like when we have the pods like very clear, when they're not overlapping, the accuracy for detection is 100%. Thank you very much, everyone. I would like to thank my team that helps me with this counting. It was a very tiring job. I would like to thank the Department of Plant and Soil Science, all the funding agents that trust us to get this problem solved, and special to Professor Krishna Jagadish, which is my supervisor, and he's the one that it's in front of this project to try to solve this problem. And I believe that if we can use the model to detect flower abortion, this will be an improvement to breeding programs, to farmers, and it will be very nice. Thank you very much. If you have any questions, I'm very glad to help you. to answer.
Thank you very much, Juliana. Your presentation was great. I love it. Especially, I'm really interested in this area. I have a question, especially about the plants. They can identify one plant, the amount of soil, the flowers in one plant, or is just a general view and counting?
Yeah, in the beginning we try it to count per plant, but if you see, it's very hard here because of the overlap between the plants. So it's very hard for you to get to see, okay, this flower is from this plant, this flower is for the other plant. So what we are doing now is just count all the flowers in one plot, which will be 2.5 meters, and then we can divide this number by the number of plants that we have in that plot. That will be an option. But if we can get the abortion as well, we don't need to do the number per plant.
Got it. Thank you. And we have some questions in the chat too. I don't know if you can see it. If
Now,
you can't, I can tell you.
yeah, if you can see it.
Okay. Afrânio Gabriel, he thanks for the presentation, Juliana. I've started to work with CNN, and I have one question. Which platform do you use to make a bounding box in the field videos?
For detection, we use Label Me, and for the tracking, we're using CVAT, CVAT.
Thank you. Any more question, guys? So, thank you very much, Juliana, again. Great representation and super interesting job in
Thank you very much.
research.
It's a very challenging, but it's very fun.
I imagine it's a really new thing. I think it's the first thing I see anything related.
Yeah, and it's hard when you're an agronomist and you don't have much knowledge about machine learning. So in the beginning, I had to lay a lot in computer scientists, and then there is this problem where they don't know what is a flower and they don't know what is a pod. It's very hard for them to do this job of annotating. So I had to jump in and start learning like to code and how this whole process happened, so I could have more accuracy in my model. Because if I let to them to do it, it would not be that good. Because when I was looking at their annotation, I'm like, this is a flower. Why are you missing that? But like, I don't see a flower. It's very fun.
I got it. We have some more questions. So, Anna Mercedes have, if I leave a leaf, should I get in the front of the camera, can it interfere in the power counting?
What is the question? If
The
I
leaf,
if I leave, get in front of the
I
camera.
think it's the
Oh,
point.
yes. Yeah, you will have the occlusion. So we are not trying to get the total amount, like not even us doing the manual count, because you have a plant. Last year we had a plant that had 500 flowers. So it's insane to count everything. But we want to have the amount of count that we can see the difference between the genotypes. This is a test to find differences between genotypes. And like if a farmer has a area where this part of this area he puts irrigation, and this part he doesn't, and he want to know if like just the rain here it's enough, and he's having more abortion land, he can do it. So he can compare, okay, here I have 20%, here I'm having 30, or some difference in the land, that here the water doesn't drain that much and here it drains. Do I have difference in flower abortion? You might find it. That's the importance of this test, because you can test if it can cause diversity in the field, and then see if it's affecting the flower, which will affect your yield in yield.
Got it. And we have some more questions too. You can see it. We have Javier and Julia.
Oh yeah, how did you calibrate the model? So the calibration is made about our ground truth. So the model, we need to compare what I teach the model, and then we'll try to predict. It's more a teaching process that do the calibration. If this is what you want to know. The next question is perfect presentation. How can they or you be preventing that person? Yeah, for flower abortion in soybean, you cannot have like a genotype that doesn't abort at all. You will have some percentage, even if you do the perfect. But what we this project, it has a lot of breeders, and they're trying to find in this 228 lines, which most of them are wide species, if some of them have some genes that could lower this abortion, even if I'm in a stress condition. Let's see the next one. It's
Estranho, Gabriel had one too.
That's big challenge here. Process the data, and we try to use solutions like cloud computer. Yeah, here we're using Amazon Cloud for storage, and I'm gonna tell you, it's a lot of storage. It's like 5 terabytes just from one location, from all the videos that we do. So what we are trying to do for next year is like not imaging the A phi plot, maybe just 3.3, which would be just a meter, which is basically what we harvest for yield. So next year we want to put two labels where I just image this part, and then I want to get the abortion from that. And then we might have less data to work with, because right now I have maybe 10 days of data, and I'm still uploading all this data into the cloud. And yeah, Afrani, it's this is one of the things that you need to have a very good computer and good internet to work with all this data. The accuracy of our model right now, it's around 80% for flowers, and for pods, because we are having the overlap of the pods, it's like 58%, but we tend to increase it with more training and trying new techniques. I think that was the last question.
Yeah, I think it is. And thank you so much, Juliana, with that. And we conclude the first day of the presentations. And if you need JC for something, or if we can settle something, it would be great for us. Your presentation was really good. Your accent is perfect.
Thank you very much. Yeah, if you want to contact me later for more questions, feel free. I'm always open to. I know that this topic is very interesting, and sometimes the question comes later. So thank you very much, guys.
Thank you.
Bye-bye.
So, guys, it was it. Thank you very much for everyone that stayed to here and participate to the webinar. And I see you tomorrow. Thank you.